Okay, so for this problem, we're going to take a look at the 10% and 25% trimmed means for the salaries of the U.S. governors as of 2007. To figure out the trimmed means, first off we have to eliminate the top and bottom portions of the data. So for example, for the 10% trim mean, we know full well that 10% of 50 governors, there's 50 things in the data set, well, 10% of 50 is obviously equal to 5. And so what I have to do is ignore the top 5 and bottom 5 numbers. So I'm going to just simply highlight these in yellow just to say that I'm not going to use these numbers. And so the 10% trim mean will be the average of the 40 numbers that are left. So just simply typing that in, we have that this is equal to the, let's do it on the screen so you can see it. This is equal to, do it over here, equal to the average. Let me pull this out also. Average of, let's see, A6 to A10, also B1 to D10, and E1 to E5. So highlighting those 40 numbers, and let's figure out what the average of those numbers are. So the trimmed mean would be $113,358.15. So this would be the 10% trimmed mean. Looking at the 40 numbers in the middle, eliminating the lowest 10% and the top 10%. Now for the 25% trim mean, we have a complication. So, which is that if we figure out what 25% of 50 25% of 50 is 50 divided by 4, that's 12.5. Now clearly I can't just simply eliminate 12 and a half governors. So I can eliminate 12 governors, I can eliminate 13 governors, but I can't get rid of 12, or 12 and a half. So the way that I'm going to go about this is I'm going to figure out the percentages that go along for 12 and for 13. So I'm going to figure out 20, 12, and I figure out 13, and then I'll interpolate. So doing both of those, 12, that's 24% of 50, while 13 is 26% of 50. So I will figure out the 24% and 26% trim means first. So let me get rid of this, and then we no longer need it. So for the 24% trim mean, I will eliminate the top 12 and bottom 12 numbers. So there's the ones in yellow I will ignore. The ones that I will calculate are in white. So the average of these 8 numbers, as well as these 10 numbers, as well as these other 8. So this average, that is the 24% trimmed mean. I will also figure out the 26% trimmed mean, which I obtain by eliminating the top and bottom 13. So now I will do the same kind of calculation except with the ignoring the top 13 and bottom 13 numbers. So the average of the middle So if I take this average, I get something a little bit different, not much different as you would expect, and that's the 26% trim mean. Okay, so now that I have these numbers, what I need to do is to interpolate. In other words, let's see. So let me let's draw a little chart here on my Paint program. So basically, I'm going to pretend I've got those 2 points. So pretend here's 24. Pretend here's 26. And the numbers that I had were these numbers here. The first one was 111628. and a few cents. 628 and 42 cents. So that's this point. And the other point was 111, 482 and 13 cents. 111, 4, I've already forgotten, 482 and 13 cents. Okay, and that makes another point. So I've got the 24% and the 26% trim means, and let me mark those with the proper decimal, 0.24 and 0.26. The one that I really care about is dead smack in the middle, and hopefully that's about in the middle, at 0.25. So my 25% trim mean will be obtained by basically drawing a line between these 2 points, and whatever the coordinate is that corresponds to 0.25, that'll be the number, the y coordinate that comes out will be the number that I care about. Now in this case it's easy. 25% is exactly halfway between 24% and 26%, and so I can take the average of these two numbers, and that will be the 25% trim mean. That's a lucky accident for this problem. If the number in black here was, say, over here someplace, then I could take some kind of weighted average, or I could just literally find the equation of the line between these 2 points and then figure out, there's my x-coordinate, then figure out the y-coordinate that goes with it. Okay, so my 25% trim mean in this case is easy. It'll just simply be the average of these two numbers. The average of those two in this case is easy, and so my answer is $111,555,000.28 or 27 cents. I encourage you to practice this on your own to actually find the equation of the line between these 2 points, then plug in x equals 0.25 and make sure that the y coordinate that you get out is equal to this, because that is the more general method of being able to find the trim mean if the point's in between. So I have to interpolate between these 2 points to figure out the y coordinate in the middle. So that's how you figure out the trim mean if the number does not, if the r% does not work out to be exactly an integer.